The next sorting algorithm we're going to learn is the count sort. So a sorting algorithm that sorts the element of an array by counting the number of occurrences of each unique element in the array. So that is what a count sort is. Count sort is sorted in an auxiliary array, and sorted is done by mapping the counted as the index of the auxiliary array. Alright. So it's a very efficient algorithm. So what actually count sort means is a counting sort algorithm is a sorting technique that works by determining the count of each unique element in the input array and that information to construct a sorted output array. So what you're going to follow is okay, let me tell the algorithm what actually it follows, how it goes. So what is the approach, like how it is designed, let me tell you. So we're going to define the array, input array num, that needs to be sorted, right? And we're going to get the length using some variable, and after that we're going to find the maximum element in the array by iterating through the element. Then we'll create a count array of size max plus 1 to store the count of each element, and iterate through the input array and increment the count of each element in the count array. Then we'll modify the count array to contain the actual position of each element in the sorted array by adding the previous count to the current count. Then we'll create an output array of the same size as the input size to store the sorted elements. We'll iterate through the input array in a reverse order and place each element in the correct position in the output array based on the count array. Then we'll decrement the count of the element after placing it in the output array, and we will copy the sorted element to the output array. So this is the algorithm for that, and the time complexity of count sort algorithm is O of n plus k. So where n is the number of element in the input array and k is the range of the element. So count sort is efficient when the range of element is relatively small compared to the number of elements. So however, it requires additional space for the count of input array. So space complexity is also going to be n plus n, n plus k complexity, only O of n plus k. So let's try to go to the VS Code and see how it is done. I'm going to explain each and everything how this count sort algorithm is designed. Alright, so let's jump to the VS Code and understand about this. Now we jump to the VS Code. Here we're going to see the count sort algorithm. So for that I'll write let's say counting sort .java, and it has a specific some needs are there that's going to be fulfilled, and that's going to happen, right? So we will write each thing one by one here. All right, so first of all I'll declare the public static main void. For that, the main method we're going to declare. All right, so what I'll write is I'll write public static void main method, and in this main method I'm going to pass the string as usual we used to do. So string array we have taken, and args I'm going to take. Now in this I'm going to take the array. So let's take one array, like int of one array. I'm going to take, let's say, array name to be nums, and in this let's take value 5 comma 3 comma 8 comma 2 comma 1 comma 4. Let's say these are the values we are taking. Okay, now what I'm going to do is we're going to call the counting sort function. So counting sort function I'll be declaring, and here I'm going to nums. All right, so I'm going to declaring this counting sort function. Here I'll be calling it. Now after calling it, I'll get here system.out.println, and in this I'm going to write sorted array. Sorted array is, and it's going to print the sorted array. So for printing the sorted array, we'll go to the run a for loop. So for loop we'll write it as in for each loop. So we get getting practice with this for each loop. So I'll take one variable for num. For each num variable in array, not array, nums array, right? That is name of the array is nums array. We going to print it. So system, we're going to print num, system dot out dot println, not println, let's write print. So it's not going to go to the next line. So let's write num variable concatenation, I'll give some space to it. Okay, now this main method is done. Now we have to write the counting sort algorithm, like function, right? So for that, what I'll do is I'll come out of here, and here I'm going to write the function. Let's say I'm going to write in private, static void counting sort, count sort, and here we going to, in this counting sort, we're going to pass the array, int array nums array we are passing. All right, after passing the nums, I'm going to come out of here, and here we're going to declare the length of the array. So int n, let's say, and length is going to be nums dot length. Okay, so this is done. All right, so okay, it is giving error, so I have to write nums. Okay, now it will not give any kind of error. This has to be written outside the main function we are writing inside the main function. So I have to take out of this, control X, and it's going to be out of this main function. We are writing inside the class counting sort, right? Okay, now it's good. Okay, what I have to do is find the maximum element in the array. This is one first algorithm, like first step we will applying is find the maximum element in the array. So how to find the maximum element in the array? That will declare the first value. Either we can declare with the minimum value or the first value of the array. You can do both. So this time I showed many times that choosing the minimum value for the maximum, right, initializing. Now I'm going to choose the first element, right? So I can choose that, right, and it will get automatically updated. So I'll write nums array, and first element we are choosing, we are considering that is the largest element. I'll write what, for loop. Inside this I'll start int I equals to 1. I have considered the first element to the maximum element, so second element I have to start from less than n and I plus plus. Here I have to compare if nums of I, if nums of I is greater than max, if nums of I is greater than max, then what I have to do is I have to update the max with nums. That's how we're going to get, we did numerous times this kind of stuff. So this is going to give the value. So if you iterate, you will know that okay, this is updating the value every time. So this is finding the maximum value is done. Now I'll create an array to store the count of each element. I'll create an array to store the count of each element. Okay, how to create an array? So we already know we can create by writing int, and let's say count array I'm creating, that's the object we're giving, new, and int, and size I already told that max plus 1 is going to be the size. So we're going to take size 1 greater than the max value, right? So now what I have to do is store the count of each element in the count array. What I have to do is I'll have to store the each element, store the each element, store the count of each element in the count array. Okay, so here how to do it? So for that I'll write a for loop. It's very simple. I'm going to write int I equals to 0, I less than n is going to go, and I plus plus. Alright, now what we're going to here is, we're going to write count array. In that I have to store the count of each element. So whenever the num is going to come, that is nums array, right, nums array I is going to come, that time I'm going to increment it. So it will increase the count of each element. Alright, this is the for loop for storing the count of array. Now count of each element in the array. Now I'll modify the count array to contain the actual position of each element in the sorted array. So what I have to do is modify the count array to contain the actual position of each element in the sorted array. Okay, why we are doing that, I'll let you know. Let me write the algorithm first, otherwise it will get error. Alright, so I'll miss something and it will give error every time. Okay, so what I have to write is we are modifying the count, right? So what actually doing is we're going to take for loop and int I equals to from 1. I'm going to start and I'll go till the max element, and max will be included in it, I plus plus. Okay, now what I'll going to do is count. I'm going to write count array, count of I, that is going to be equals to count of I plus count of I minus 1. I have to add this previous element and that current element I minus 1. So that is going to update the value of the count every time. Now what I'll do is I'll create a temporary array to store the sorted output. I'll create a temporary array, create a temporary array to store the sorted output. How to do temporary array? I'll create int let's say output array I'm creating, all right, and equals to new int size. What size will be giving? Will be giving size as n from the above, so that is going to be the size of the array. Now what I have to do is I have to build the sorted array by placing elements in their correct position. So build sorted. So these all are the algorithm. This is how it's going to be done. All right, build sorted array by placing. If you do iteration one by one, that will actually you'll find how it is happening. All right, element in their correct position. Okay, now what I have to do is for that I'll write a for loop. I'll start from the last and I'll like get back to the, like we have to get that in the original position, right? So in the correct position, what we say, so we're going to start from int I equals, I'm going to start from the last and I'm going to decrement it and I'm going to get it to that position. So I'll write I is greater than equals to 0 until unless I greater than 0. Run this and I minus minus is going to decrement it. And what you do is in the temporary array you created output, in that count array is there, and in that num array of I is there. So that is going to be there with, we're going to minus 1, and this is going to be getting from where nums of I, and this is not going to be num, this is going to be nums. Okay, what does this mean? We're going to talk about it. All right, so and we're going to decrement the count. So count array of nums in that I, and we going to decrement this also. Okay, this is what we did. This we copied all the things. This is we build it. Now we'll copy the sorted element from the output array to the original array. So now what we'll do is copy the sorted element from the output array to the original array. Okay, so this is very simple. We're going to write for loop. So we're going to write one for loop, and in this for loop I'm going to start with int I equals to 0, I less than n size of that array, and I plus plus. Here we're going to copy, it means nums of I in that, this is the original array, nums of I, and where we build it in the output, right? So output array of I. So this is going to copy all the things. Okay, now let's see one by one what we actually did. This is all over of that thing. Okay, now this for loop, okay, this is very simple, that we have called the function and counting sort. Okay, this for loop is there. This loop iterates through the input array to find the maximum element, that is max. So it starts from the second index I equals to 1 and compares each element with the current maximum. If a larger element is found, it updates the max to the element. So this step is basically necessary to determine the size of the count array, because the size of the count array is going to be max plus 1, right? So now next loop we have taken is, this loop is actually what it is doing is, this loop iterates through the input array, this iterates through the input array and increments the count of each element in the count array, increments the count of each element in the count array. So it uses the element as index in the count array. This is using the as the index in the count array and increments the value at that index. This is what it is doing. Now, okay, if I go to this modify the count array, here it is doing that this loop actually modifies the count array to contain the actual position of each element in the sorted array. So it starts from second index I equals to 1 and adds the previous count to the current count. It is adding the previous count to the current count. So this steps basically ensures that count array now represents the static index of each element in the sorted array. Now if I come down here, temporary array is created and that is the output, and we're going to build it, right? So this loop actually iterates through the input array in reverse order. This loop iterates through the input array in reverse order. So it takes each element and place it in the correct position in the output array. So based on the count array, the element is placed at output of this. So if you just take that array and put all the elements, you're going to find it how it's reversing it, right? After placing the element, the count that element is decremented. We're going to come back, right? And at the last, we're going to copy the sorted elements from the output array back to the original num array. So it assigns each element in the output array to the corresponding index of the nums array. So like basically what it is doing, updating the original array with the sorted elements. So this is all the counting sort algorithm is. All right. Okay, you have to remember the steps, what steps you have to do, and this is all about it. Now, okay, I didn't hit Control S. I'll cross it. I'll hit Control S. Save this code. Okay, it is showing somewhere error is showing. Where is the error? Let's find the error. What error we did? Okay, so main method we have written. Let us see syntax error in line number 46. It is talking about. Okay, here we didn't give the Control S. Line number 13 it is talking about. What is there? I think no error here. I guess nums is the array. If I see, okay, now is everything okay, and let's run this code. Okay, so after running this code, let's wait for the output it is giving. So the sorted array is 1 2 3 4 5 8. So this we have taken 6 size and it is coming as a 6 size, and same thing, same, we got the sorted result. If you want to print the original array, you can do that. Now we're going to go to the next sorting algorithm, that's going to be the bucket sort. Thank you.